You may have heard that pulse plating offers savings in raw materials, energy, and additives. This quick presentation will show you the basics of how pulse plating covers the lows faster without chemicals, reducing plating time and cutting costs. In much the same way magnets are attracted or repel from each other based upon their pole, positively charged particles are repelled from each other and attracted to negative surfaces. In this simplified diagram we have a raw material anode and a part to be plated and zero voltage is being applied. The part has areas that are closer to the anode and areas that are further away. When we apply voltage to the system, particles are positively charged and separated, or corroded, from the anode. The particles then make their way from the anode to the nearest negatively charged point and only heat, agitation, and collision with other particles would change these paths. This is why with straight DC you typically see a 1:5 plating thickness ratio between the thickest plating and thinnest plating. Remember that the positively charged particles repel each other. With pulse we turn off the voltage for a short period which allows the particles to redistribute, changing their path. We apply the voltage and the particles again head towards the closest negatively charged surface. The next voltage 0 pulse occurs and the positively charged particles again redistribute. It's important to note that the particles are always repelling each other, even during on cycles, it's just that the charge can overpower that effect. The voltage on pulse occurs and the particles continue their journey. We continue this cycle over and over at a high frequency. As the particles begin to plate with pulse we have a better distribution of particles. This is also where chemistry is often used to make up for the shortcomings of normal DC rectification. Here we see the particles are finally settled and more evenly distributed. Again, this is a simplified model and there are many more complex interactions and variables in a plating bath that are beyond the scope of this video. You may be asking, how does pulse save time and money? Remember that typical DC plating has a high to low ratio of 1:5. However, with pulse plating, we can achieve ratios of 2:5 or higher. But remember, you plate to the lows. So instead of plating 2 mils to the lows you plate 1 to meet spec, which means the highs are plated to half as much. Different processes in metals have different outcomes but almost always see substantial improvements in distribution and speed of plating. In the end we have customers that have seen around 30% savings in raw materials, and have doubled their plating speeds. We hope this video has given you a basic understanding of one of the many advantages of pulse plating, namely the advantages of improved current distribution. For more information and to learn about the most advanced pulse rectifiers on the planet, visit our website at ionrectifiers.com. Proudly made in Texas, Ion Precision Products is a veteran-owned company.